and solid science to help you feel confident and prepared. The first question, Wanjiku saw this sign on a certain container. So this is the sign that Wanjiku saw. Then the question is, what does this laboratory symbol mean? A, corrosive. This is not the sign for a corrosive substance because corrosive substances are represented by a symbol here on the screen. Then B, flammable. This is not the symbol to represent flammable substances because flammable substances are represented by a symbol which looks like this. And then C, toxic. This is not the sign which represents a toxic substance because toxic substances are represented by a symbol which looks like this. And then D, radioactive. This is correct. A radioactive substance is represented by the symbol which you can see here on the screen. And remember, a radioactive substance is a substance which is able to emit radioactive rays. Question 2, a mixture of sand and iron, in this case, let's underline this, sand and iron, was given to students. Mary suggested using a magnet to separate them. Why is this method effective? Why do we have to use a magnet to separate a mixture of sand and iron filings? Now, for you to use a magnet to separate a substance, then it means the substance must be magnetic. A substance which is magnetic, it must be attracted by a magnet like you can see here on the screen. The substance that you see here is what we call a magnet, and then what is being attracted on these ends of a magnet is what we call a magnetic substance. So for a substance to be separated using a magnet, then one of the substances must be magnetic. Now in this case, let's see why this method is effective. A, sand is heavier. This is not right. It's wrong. Iron is magnetic. That is right, because we have said for a substance to be separated using a magnet, one of it must be magnetic. Sand dissolves in water. We don't have water in this case. Then iron filings float. We don't have any substance where floating can take place. So the correct answer here, the reason why Mary suggested that this substance can be separated using a magnet is because iron is magnetic and sand is non-magnetic. Third question, the image below shows types of circuits. Which one represents a short circuit? Before we look at the options given, let's look at what is a short circuit. A short circuit occurs when the wire creates a direct connection between the battery terminals, hence bypassing the bulb, and in this case it can lead to the destruction of the bulb. So now let's look at the options given, keeping in mind that we are looking for a direct connection between the two terminals of the battery. The first option here, A, there's a wire from the positive terminal to the bulb, then from the negative to the bulb. In this case, there's no direct connection. Then in this case, this is not a short circuit. B, we have a wire from the positive terminal to the bulb, negative terminal to the bulb, but in between here, there's a direct connection between the wire from the negative terminal to the wire from the positive terminal. Therefore, in this case, this is a short circuit because from the definition of a short circuit, there must be a direct connection between the terminals of the battery. Then C, we have a wire from the positive to the bulb, negative to the bulb, but in between here, there's a disconnection. So this one, we call it an open circuit. This is an open circuit, therefore it's not a short circuit. And then D, we have three wires from the positive terminal to three different bulbs. Then from the negative terminal, we have one wire, and then there's a connection to the bulb. Therefore, in this case, this is as a circuit with bulbs in parallel. Therefore, in this case, this is not a short circuit. Therefore, the short circuit that we have in this case is B, where there's a direct connection between the positive terminal of the battery to the negative terminal of the battery before the current reaches the bulb. Question 4. In a science lesson, Diana poured oil into water and saw that the two liquids did not mix. What kind of mixture is this? A, a solution. B, a suspension. C, emulsion. D, colloid. So we're going to discuss an emulsion and colloid later, but in this case I want us to briefly discuss a solution and suspension. Now, a solution is a substance which is formed when a solute is mixed with a solvent. Now, what is a solute and what is a solvent? A solute is a solid substance which can dissolve in a solvent, and in this case a good example is salt. Then a solvent is a liquid substance in which a solute can dissolve in, and a good example in this case is water. Therefore, for you to form a solution, you must have a solid, which is a solute, and a liquid, which is a solvent. But in our case, Diana poured oil and water, which are both in liquid state. Therefore, it can never be a solution. Then B, a suspension. A suspension is formed when two immiscible liquids are poured together. Immiscible liquids, these are liquids which can never mix due to their difference in densities. Therefore, in this case, when you pour oil and water, they form what we call a suspension, like the one that you can see here on the screen. So therefore, in this case, what Diana formed was a suspension. Then question 5, the diagram below shows a human male reproductive system. So we have a male reproductive system labeled A, B, C, D, E, and F. And then the question is, which part produces sperm cells? Sperm cells are produced by testes. Now, which part in this diagram represents testes? So I want to introduce a diagram which is labeled. So in this case, you can see this is a male reproductive system and it is being labeled, and now we need to locate the part which is for testes. So in this case, you can locate this part here, and this part is matching with the part on the question which is labeled F. So the part labeled F is what we call testis, and is the one which is responsible for the formation or production of sperm cells. Question 6. Salim suffered a minor burn on his arm during an experiment. What is the first aid procedure? A. Rub with lotion. This one is wrong. B. Put in cold running water. This one is right. It's one of the procedures for minor injuries. C. Apply butter. This is wrong. D. Cover with cloth. This is wrong. So the correct answer here is put in cold running water, which is B in this case. Question 7. The instrument below was used by a student in the lab. What is the reading of the vernier calipers? So the instrument is called the vernier calipers, as shown in the figure below. So in this case, you have been notified that one small division is equals to 1 millimeter in this main scale. So this main scale is given in centimeters, but one division between 2 points in this case is 1 millimeter. Therefore, in this case, the first thing that we need to have is that we must know the scales that we have here. The upper scale, which is labeled in centimeter, is called the main scale. Then the second scale below here is known as vernier scale. This is the vernier scale. And the vernier scale has 10 divisions. So when we are making readings, we must read the two scales. But another important thing that you need to know before you make a reading is that the accuracy of the instrument. The accuracy is the smallest division that you can read from a measuring instrument directly. So in this case, for a vernier scale, the accuracy is 0.01 centimeter. Therefore, now for us to make a reading, then we need to read the two scales. The first scale, which we call the main scale, we read it in centimeters. So in this case, we are going to read it and it's going to be in centimeters. Then the second scale that we are going to read, that is the second scale. In this case, we are going to read the vernier scale. Vernier scale divisions. In this case, we are not going to read in terms of distance. We want to read the divisions, and in this case we will indicate the number of divisions here. Then now for us to get total reading, total reading. Then in this case, we must add the main scale, let me indicate it by MS, plus the number of divisions, of the vernier scale divisions. But this one, we must multiply it by the accuracy. The vernier scale divisions times the accuracy. Therefore, in this case, let's read the main scale. How do we read the main scale? We read the main scale by looking at the 0 mark of the vernier scale. This 0 mark here of the vernier scale. We move up, and then the value which is on the left side of the 0 mark of the vernier scale. So in this case, we read as 1.1. So the main scale reading is 1.1 centimeter. Then the vernier scale, we read the value which coincides with the main scale. The value which coincides with the main scale, it means if you have a vernier scale down here, vernier scale, and the main scale up here, then you can have these marks which are not in the same line, but there's a line which will be in the same line from the main scale to the vernier scale. So when it's like this, we call it has coincided. Therefore, in this case, let's look at the point which is coinciding. 0, 1, 2, 3 is not coinciding, 4 is not coinciding. These 5, where we have the 5 in the vernier scale, that mark is coinciding with the main scale mark. So in this case, we have 5 divisions. Remember, the vernier scale we read in terms of divisions. Therefore, in this case now, for us to get the total reading, then we have to take the main scale, which is 1.1 centimeter, plus the number of divisions of the vernier scale, which are 5 divisions. We said we must multiply it with the accuracy 0.01 then centimeter. Therefore, in this case, we are going to have our total reading as 1.1 centimeter plus 0.05 centimeter. 5 times 0.01 is 0.05 centimeter. Now, when we add the two, we are going to have our total reading as 1.15 centimeter. Therefore, the correct answer in this case is 1.15 centimeter, which is A. Question 8. Grade 7 learners visited a certain hospital and the doctor displayed the part of the heart and asked them a question. So this is the heart that the doctor displayed, and this is the question. The blood vessel labeled 1 is called, so in this case we have this blood vessel labeled 1. What is its name? So before we respond, let's first look at the structure of the heart. In this case, we have the pulmonary vein, we have the left atrium, we have the mitral valve, we have the left ventricle, we have the septum, we have the right ventricle, we have the tricuspid valve, we have the right atrium, we have the superior vena cava, we have the aorta, and then we have the pulmonary artery. So this blood vessel which we have here, let's call it 1 on this right side, is the same blood vessel that the doctor asked the learners. Therefore, in this case, the name of the part labeled 1 is pulmonary artery. So this is the correct answer in this case, B. Question 9. A student used a red and a blue litmus paper to test a solution. Both papers stayed the same. So it means red remained red and blue remained blue. What is the solution? So before we look at the options, let's look at the diagram here on the screen. The first one here, it has a pH of less than 7, and in this case we call it an acidic solution. And in acidic solution, you can see we have a blue litmus paper which has turned red below here. You can see that. And then the red litmus paper has remained red, as you can see on top and below there. Then the second diagram that we have is a pH of 7, and in this case we call it a neutral solution. And in a neutral solution, I want us to look at the two cases. A blue litmus paper has remained blue, and a red litmus paper, this red, it has remained red. Then now we have the third case, which has a pH of more than 7, and we call it a basic solution. In a basic solution, I want us to look at the litmus paper inside it. Blue, this blue litmus paper has remained blue, and then the red litmus paper up here has turned blue. Now the question was, this student tested using a red and blue litmus paper, and the two papers remained the same. On the screen here you can see the condition where the two papers remain the same is where we have a pH value of 7, and we have called it a neutral solution. The blue litmus paper has remained blue, red has remained red. So therefore in this case the correct answer is that the solution is neutral, that is the A. Then question 10, a kidney removes excess salt and water from the body. Which process is this? A, circulation? No, this is for the heart, blood circulation. B, excretion. This is the removal of waste products from the body. So in this case, this is correct because here we are removing excess salt and water. Digestion? No. Absorption? No. So the correct answer in this case is excretion. Question 11. Identify the appliance below. This appliance is used in most homesteads, and it's one of the components which use electricity. So in this case, we are supposed to identify this appliance. So A, water heater? No. Flat iron? Yes. Kettle? No. Blender? No. So in this case, the correct answer is a flat iron, which is used to iron clothes. Question 12. The SI unit of temperature is, so before we look at the options, let's note that temperature is a basic quantity, and a basic quantity is a quantity which you cannot obtain from other quantities. And we only have 7 basic quantities in science, or sometimes we call them fundamental quantities. And the first one is what we call length, which is measured in meter, mass, which is measured in kilogram, time, which is measured in second, temperature, which is measured in Kelvin, electric current measured in ampere, amount of substance measured in mole, luminous intensity measured in candela. So in this case, the correct answer for the SI unit of temperature is Kelvin. That is option D. These other units are used, but they are not the SI units. Question 13. Identify a method suitable for separating chalk from water. When you have a mixture of chalk and water, chalk is a solid which cannot dissolve in a solvent, which is water in this case. Therefore, in this case, for you to separate, you must use a method which you can see here on the screen. And this method is called filtration. And in filtration, you obtain a filtrate. A filtrate will be the liquid in the mixture. And then you will also obtain a residue, which will be a solid in the mixture. So in this case, our solid is going to be the chalk, and then the liquid is going to be water. Therefore, for you to do filtration, you need a beaker, which will contain the mixture. Then you need a filter paper, which will trap the residue. You need a filter funnel, which will facilitate the process. Then you need a conical flask where the filtrate will drop into. So this method of separation is called filtration, which is C. Then another question, the diagram below shows 2 bar magnets. So in this case, we have a magnet. And what is a magnet? A magnet is a substance which can attract magnetic materials. So these are 2 magnets. These are magnets. And what you should note is that magnets have 2 poles. This is what we call a pole, and this is what we call also a pole. This is a pole, and this is also a pole. So a magnet has 2 poles. Like the first magnet here has north pole, which is labeled N, and south pole labeled S. The second one also has north pole and south pole. Now the question is, what poles are facing each other? What is the name of the poles facing each other? So in this case, for us to have a repulsion, in this case you can see the two poles are close and there's a repulsion. For you to identify or to answer this question, then you must first know what we call the basic law of magnetism. The basic law of magnetism states that like poles repel while unlike poles attract. So if you have two unlike poles, they will attract, and if you have two like poles, they will repel. Like in this case on the screen, what you can see as our first diagram here, we have south pole close to north pole, so these are unlike poles. So in this case they will attract. And then the second diagram, we have a north pole close to north pole. In this case you can see there's a repulsion, they will move away from each other. Then the third case here, we have south pole and south pole. Since they are like poles, they will repel, and you can see they are moving away from each other. So this one satisfied the law of magnetism, which we say like poles repel while unlike poles attract. So in this case, for this repulsion to take place, then there must be like poles close together, and in our case we have north pole and north pole. So the correct answer is B. The poles which are close to each other or which are facing each other is north pole, which is labeled N, and another north pole, which results to a repulsion. Question 15. Jane was asked to record the time taken for water to boil. Which SI unit should she use? A. Celsius, B. Seconds, C. Minutes, D. Liters. So we said time is an example of a basic quantity, and the SI unit of time is second. So in this case, Jane should have recorded in seconds, that is B. Celsius is another unit used to measure temperature, minute is a subunit of second, and then liter is for volume. Then question 16, which component of integrated science deals with acids and indicators? Remember, we have three main components of integrated science. The first one is life science, and in life science we deal with living things where we learn biology. Then the second component of integrated science is physical science, and in physical science we study subjects like physics. We study subjects like physics and chemistry. Then the third component of integrated science is earth science, where we deal with geology and astronomy. So these are the three main components of integrated science. Social science is not part of a component of integrated science. Now, where does acid and indicators lie? Acids and indicators are under chemistry. This is where we study acids and indicators. Therefore, the component of integrated science that deals with acids and indicators is physical science, which is B. Question 18. Ali observed that a bar magnet attracts pins, but a plastic rod does not. What can we conclude? So in this case, Ali observed that if we had a magnet like this is a magnet, a substance that can attract magnetic materials, then this magnet attracted pins. Pins are example of magnetic material, a material that can be attracted by a magnet. Then in this case, let's look at the options given. A, plastic is magnetic. No, because a magnetic material must be attracted by a magnet. In this case, plastic is not. Then B, pins are non-magnetic. Pins are magnetic because we are told this magnet attracts pins. Then C, only metals are useful. No. Then D, magnets attract magnetic materials only. This is correct. So in this case, we can conclude that a magnet can only attract magnetic material. And an example of magnetic material in this case, these are pins. These are magnetic. magnetic materials. Then question 19, during a separation of mixture lesson, learners were presented with the following setup. So you can see a setup here where we have a Liebig condenser. This is a Liebig condenser. Then this is water inlet. Then we have up here water outlet. Then we have a thermometer. This is our thermometer. We have a clamp and stand here. Then we have a Bunsen burner. Then of course we have a round bottomed flask. It's very important for you to know these things. Then we have a delivery tube. This is a delivery tube. Then we have a conical. This is a conical flask. So this is the setup that we have. Now, what method will be best separate this mixture? In this case, the mixture which can be separated using this method is a mixture, or this method is called distillation. And if you are keen enough, you will note that on this diagram that we have, we don't have a Liebig condenser, no, not a Liebig, but we don't have a fractionating column. A fractionating column should be at this point here. Therefore, this method is called a simple distillation. Question 20. The image shows a broken beaker with spilled acid. So in this case, you can see this is a broken beaker, broken glass beaker, and you have a spilled acid on the floor. Then the question is, what is the first step you should take? A, wipe it out with a cloth. This is wrong because it can injure you. Call a teacher. This is correct. You call your teacher. Ignore it. This is wrong because it can injure you or even your friend. Then D, add water. This can even make it worse. So the correct answer is B, call the teacher. Question 21. Which of the following is the characteristic property of acids? Which of the following is the characteristic property of acids? A, they turn red litmus paper blue. This one is wrong because if you look at the diagram here, when we have the first substance we have here is acidic. Then this one, the second one is neutral. Then the third one is basic. So in this case, in acidic, you can see this blue litmus paper has turned red and red has remained red. So in this case, they turn red litmus paper blue. This is wrong. B, they have a pH greater than 7. Let's look at the pH value you can see indicated here. Acids have a pH of less than 7. Then bases are the one which have a pH of greater than 7. So this one is also wrong, because acids have a pH of less, not greater than 7. Then C, they react with metals to produce hydrogen gas. This one is correct, because if you have an acid, then you react it with a metal, it will produce a salt plus hydrogen. A good example is if you have an acid like sulfuric acid, you react it with a metal like magnesium. In this case, it will give you two products. One, it will give you a salt which we call magnesium sulfate, which is a salt, plus hydrogen gas. So this one is correct. Then D, they feel slippery to touch. This one is for bases. So the correct answer in this case is that they react with metals to produce hydrogen gas. Question 22. During a demonstration, the teacher mixed iron filings and sulfur and heated them. What type of change took place? Before we look at the options given, let's first look at the type of processes that we have. The first type of change that we have is what we call a physical change. Then the second one is a chemical change. Now, what's the difference between the two? Let's look at the differences. For a physical change, we define it as a temporary change in which no new substance is formed and the chemical composition of the original substance remains the same. Another property of physical change is that during this change, there may be change in physical properties like color, shape, size, even state. A good example of change in color is when you have hydrated copper 2 sulfate, which is blue. If you heat it, it changes to white anhydrous copper 2 sulfate. And when you add water to the same substance, which is anhydrous copper 2 sulfate, changes back to blue hydrated copper 2 sulfate. So in that case, there is only a change in color. And then another property of a physical property is that this process is reversible. A good example is making toys from clay, forming balls from aluminium foil, and even melting ice to form liquid water. Now, for chemical change is that a chemical change is a permanent change in which new substances are formed whose chemical composition is completely different from the original substance. Another thing about chemical change is that the physical and the chemical properties of the new substance are entirely different from those of the original substance. Then the third characteristic of a chemical change is that the process is irreversible. It can never be reversed. A good example is burning incense sticks, burning a matchstick, rusting of iron to form a hydrated iron 3 oxide, and even burning iron filings with sulfur. And in this case, if you burn iron filings with sulfur, this is iron will react with sulfur when you are burning to form what we call iron 2 sulfide. Iron 2 sulfide in this case is a new substance. This is what we call a new substance. And this substance is totally different from sulfur and totally different from iron. Therefore, in this case, the type of change which takes place is a chemical change C. Question 23. Which instrument is used to measure mass? Remember, mass we said is one of the basic quantities. It's among the 7 basic quantities. And we said its SI unit is kilogram. And therefore, in this case, we are asked the instrument which you can use to measure mass. Let's look at the options given. Stopwatch, this one is used to measure time, so it can never be used to measure mass. This one is for time. Then B, thermometer. Thermometer, we said, is used to measure temperature, so it can never be used to measure mass. C, beam balance. This one is correct. It's used to measure mass. And then a ruler, in this case, is used to measure length. So the correct answer here is B for a beam balance. It's the one which is used to measure mass. Question 24. Which of the following is a component of a human reproductive system in female? Which of the following is a component of a human reproductive system in female? So in this case, we have the first one, a penis. This one is for male. This one is for male reproductive system. B, we have a urethra. In this case, this is for an excretory system. Then C, we have an ovary. As you can see here, we have a female reproductive system on the screen. An ovary is part of a female reproductive system. Then D, we have a scrotum. This one is for a male reproductive system. So the correct answer is C, ovary. Question 25. What is the first aid response to a simple fracture? What is the first aid response for a simple fracture? A, massage the area. This one is wrong because you might make it worse. It can make the fracture widen. Bandage tightly. This one is not the correct first aid response. Support and keep still. This one is correct so that you don't advance the injury. Then D, soak in warm water. This one is wrong. So the correct answer here is support and keep still so that you don't advance the injury before you seek medical advice. Question 26. Which material is magnetic? Now, what is a magnetic material? A magnetic material is a material that can be attracted by a magnet, and most of the time they are metals. So let's look at the options given. A, wood. Wood is a non-metal. It can never be magnetic. B, glass. Glass is a non-metal. It can never be magnetic. C, plastic. Plastic is a non-metal. It can never be magnetic. Then finally D, steel. Steel is a metal, so it's a magnetic material. Then question 27, which property of magnets is correct? A, they repel all metals. Magnets don't repel metals. Magnets repel other magnets with the same pole. So in this case, this one is wrong. B, they attract non-metals. Metals or magnets don't attract non-metals. Therefore, B is wrong. C, like poles attract. Like poles don't attract from the basic law of magnetism. We say like poles repel. So this one is wrong. Then D, opposite poles attract. This is what we call unlike. Unlike poles attract. This is correct because the basic law of magnetism says unlike poles or opposite poles attract while like poles repel. Question 28. The device below converts electrical energy to light energy. Devices which convert one form of energy to another form of energy, we call them transducers. So these are transducer. Now, what is the name of the device? A, ion. Is wrong. This is not ion. B, bulb. This is correct. This is a bulb which converts electrical energy to light energy. C, kettle. This one is wrong. Then D, fuse. Fuse, this is wrong. So the correct answer here is a bulb. Question 30. Adolescents often experience emotional changes. Which is an appropriate way to manage them? What is the appropriate way of managing emotional changes during adolescence? So A, fighting. This one is wrong. You don't fight to manage emotional changes. B, talking to a trusted adult. This one is correct. C, isolating oneself. This one is wrong. Then D, ignoring emotions. This one is also wrong. So the correct one here is talking to a trusted adult. Now let's move to section B, where we have structured questions. And question 31 reads, the diagram below shows some laboratory equipment. Identify each item and state its use. So here we have 3 equipments. The first one, second one, and the third one. So let's identify the first one. This one is what we call a light microscope. This is a light microscope. And the use of this light microscope is to magnify specimens in the lab during experiments. It's used to magnify specimens in the lab during experiments. Now the second one is a Bunsen burner. This is what we call a Bunsen burner. And the function of the Bunsen burner in the lab is to provide, it's used to provide a controlled, heat source, during experiments. The reason why it provides a controlled heat source is because it has a collar where you can adjust the hotness. You can either change it to luminous, or if you want it hot, you open the air hole and change it to a non-luminous. Then the third one is what we call a conical flask. This conical flask is used for different purposes. Like in the first one, it can be used for general lab experiments. And then it can also be used to measure. It can be used to measure, approximate can be used to measure approximate volumes in the lab. Question 32. A class conducted an experiment where they mixed water and salt. Describe how they could recover pure salt from the mixture. So in this case, we are only interested with recovering salt and we are not interested with water. If we were interested with water, then in this case, we could have used a method called simple distillation. But since we are only interested with salt, we are going to use a method called evaporation. So in this case, for you to describe first, you must tell us the method that you are going to use. In this case, you would say, the class would recover pure salt from the mixture by using a method of evaporation. And in evaporation, you need these substance or these apparatus. You need a Bunsen burner. This is a Bunsen burner. Then you need a tripod stand to hold the beaker. Then in this case, you need a beaker. This is a beaker which will be holding the solution. This is the solution, a solution which is a mixture of salt and water. So in this case, you heat. Then the second step is that the class would heat the salt and the water mixture. This causes water to turn into water vapor. When you heat the solution, the water will change into water vapor at the boiling point, and in this case, it will escape into the atmosphere. So in this case, we have water escaping. This water escaping the atmosphere in form of water vapor. Then if we had a mixture of salt and water only, and this water has escaped to the atmosphere, then it means we will remain with salt. Then the third step, you will tell us the salt having a much higher boiling point would be left behind as a solid residue in the container. So in this case, once the water has gone, what we will remain with is salt. And the reason why salt does not also escape is because it has a higher boiling point. So in this case, you explain this one simply by first telling us the method of separation, that is evaporation method. Then you describe how evaporation method can be used to separate. In this case, you heat, the water will turn to vapor and escape to the atmosphere. Then you remain with pure salt inside the beaker. So question 33, use the diagram below to answer the questions. So in this case, we have a diagram of a simple circuit and we are required to use it to answer the questions. So A, the part labeled A, this is a cell. Sometimes we call it a battery. Then B, this is a wire or what we call a conductor. Then C, this is a switch. It's used to complete a circuit. Then D, this is a bulb. Then in this case, the first question, name each component C and D. So C, we have said, is a switch. And then for D, we have said it's a bulb. Then question B, what will happen when the switch is closed? If you close this switch, what will happen? One, the circuit will be complete. The circuit will be closed. Then two, another thing that will happen, the bulb will light. Question 34, explain three differences between acids and bases. So in this case, we have acids on the left side and then bases on the right side of the screen. We are going to explain the differences in terms of their properties, and also we are going to use a pH chart below here. So in this case, for acids, we say acids have a pH of less than 7. That is 1, 2, 3, 4, 5, and 6. Then bases have a pH of more than 7. That is 7, 8, 9, 10, 11, 12, 13, and 14. Then for acids, we say they turn a litmus paper to red. If you introduce a litmus paper inside an acid, the blue will return to red and red will remain red. For bases, they turn a litmus paper to blue. So if you introduce a red litmus paper inside a base, it will change to blue and the blue will remain blue. Another difference is that acids taste sour while bases taste bitter or soapy. Then another one, acids feel irritating or corrosive, bases feel slippery. And then examples of acid is fruit juice, soda, and coffee. Then examples of bases is baking soda, ammonia, and soap. Another thing in which we can differentiate acids and bases is using this pH chart. In this case, from 0, 1, 2, and 3, these are strong acids. And then from 4, 5, 6, and to 6.9, these are weak acids. So below 7, you can see they are acids. And examples, we have stomach acid, lemon juice, coffee, and other substances. Then at 7, we have pure water. And here, these substances are neither acidic nor basic, so we call them neutral. Then 8, where we have seawater. 9, where we have baking soda. This is what we call weak bases. Weak bases. Then from 11 to 14, we have where we have ammonia. In this case, we call it a strong base. So bases have a pH of more than 7, while acids have a pH of less than 7, while at 7, it's a neutral substance. Question 35. Jane got a small cut on her hand while using a scalpel. State 3 first aid steps she should take. So since we are revising, we are going to give 6, but in this case, they asked 3. The first one is that Jane should wash the cut thoroughly with clean running water and soap to remove any dirt or contaminants. The second one is that Jane should apply direct pressure to the wound with a clean cloth to stop the bleeding. The third one is that Jane should elevate the injured hand above the level of the heart to help reduce bleeding. The fourth one is that Jane should apply an antiseptic to a cleaned wound to prevent infections. The fifth one is that Jane should cover the cut with clean bandage or plaster. Then finally 6, Jane should seek medical attention if the wound shows the signs of infection or regular bleeding. Then another question is that the table below shows changes in adolescence. We have a change, and then we have a physical or emotional. So in this case, fill the correct category for each. Growth of beards, this one is a physical because you can see it is a physical change. Physical change. Mood swing, this one is emotional. This emotional change. Then breast development, this one is a physical. This is a physical change. Question 37. Study the diagram below and answer the questions that follows. So in this case, we have a diagram of a human excretory system, and we have, or it's labeled A, B, C, and D. And the question is, identify the part labeled B, C, and D. So before we answer this question, let's look at the entire part of a human excretory system. We have this part called a renal artery. We have the right kidney. Then we have renal vein. We have the left kidney. We have the dorsal aorta. Then we have a ureter. We have a urinary bladder. And then we have a urethra. Then in this case now, the part labeled A is this one here for the right kidney. Then the part labeled B is this one here for the ureter. Then the part labeled C is this one for a urinary bladder. This is C. And then the part labeled D is this one here for a urethra. So in this case, if we are told now to name B, B is a ureter. It's a ureter. And then C is a urinary bladder. So this is a bladder. And then D is a urethra. So in this case, you label this as urethra. Question 38. Name 2 common kidney disorders and one way of preventing them. So in this case, we're going to list several of them. Like you can see on the screen, we have the kidney disorder, and then we have a way of preventing it. The first one is a kidney stone. Kidney stone is prevented by drinking enough water, or what we call hydration, and also limiting salt and processed food consumption. The second one is kidney infection, which is prevented by practicing hygiene and also hydration or drinking enough water. And also we can reduce it by seeking prompt treatment for urinary infections. The third one is CKD, which we call chronic kidney disease. Can be managed by managing your blood pressure and also blood sugar, and also avoiding harmful medications. The fourth one is kidney failure and can be prevented by hydration. We can also prevent it by blood pressure control and also seeking medical care. Question 39, the diagram below shows a separation of a mixture. So we have a separation of a mixture where we have a suspension, then we have a filter paper, we have a residue, or which is an insoluble solid, we have a clamp and stand, of course, then we have a filtrate inside this beaker. Then now the question is, name the methods shown. So in this case we have a filter paper and a filter funnel. Therefore this process is called filtration. This filtration method. Then name one mixture that can be separated using this method. In this case you can separate this one by a mixture of sand and water. Since these two cannot dissolve, you can separate chalk and water and many other mixtures where you have a solid which cannot dissolve in a liquid. Question 40. Mention two applications of magnets in everyday life. So in this case we're going to list several of them, not just two. So the first one is that it's used to hold knots on a refrigerator, or sometimes what we call a refrigerator magnets. Then the second one is used in compasses for navigation. The third one is used in electric motor and generators to generate electricity. The fourth one is that it's used in loudspeakers and headphones. Then the fifth one is used in credit cards and ATM cards for magnetic strips. Then we also have another use that it's used in data storage devices like hard drives and older floppy disks. And then finally, magnets are used as magnetic resonance imaging, which we call MRI, in medicine in hospitals. Then question 41, name two properties of magnetic materials. Remember, magnetic materials, we said these are materials that can be attracted by a magnet. Now, what are these properties of these materials? Now, the first one is that magnetic materials are attracted by magnets. That is a definition of magnetic materials and one of the properties. So for you to identify a magnetic material, if you introduce a magnet to them, they get attracted. The second one is that magnetic materials can be magnetized themselves to become temporary or permanent magnets. If you have a magnetic material, you can make it a magnet by doing a process which we call magnetization. And in that process, they can either become temporary magnets or permanent magnets. Then another property is that they contain domains. We are going to discuss this one in detail. They contain domains that can be aligned by an external magnetic field. A domain is a small magnet which gives a magnet its properties of North Pole and South Pole. Then the fourth one is that they are typically made of iron, nickel, cobalt, or their alloys. So for you to have a magnet, or for you to have a magnetic material, it's either iron, nickel, cobalt, or the alloys of these metals that we have here, like steel and many other alloys. Question 42. The image shows various safety gears in a lab. So in this case, let's label them. These are goggles. These are gloves. This one is a lab coat. This is a laboratory coat. This one is a mask. And then these are boots. These are gum boots. Then now the question is, what is the function of these gears. So in this case, the first function of these gears is to protect the eyes from the chemical splashes, fumes, or flying debris. So the function of goggles in this case is to protect the eyes from chemical splashes, fumes, or flying debris. Then the second function is to protect the skin and clothing from spills, splashes, or corrosive substances. This one is for the lab coat. Then another one is to prevent contamination of experiments or samples from the user's hands. Then the last one is to provide a barrier against heat or flames. These gloves, gumboots, they also provide a barrier against heat or flames in the lab. Question 43. The table below shows different instruments and their functions. Then complete the missing functions. So in this case, we have an instrument and its functions. The first one is a thermometer, and then the second one is a beam balance. So for a thermometer, its function is to measure temperature. Then the second one is a beam balance. Its function is to measure mass. Then question 44. Identify the components of integrated science. In this case, we said we have three main components of integrated science. The first one is life science, where we study biology, which is the study of living things. Then the second one is physical science, where we study two main subjects, that is chemistry and physics. And then the third one is what we call earth science, and in this case we study astronomy and geology. Then question 45. State 2 reasons why we study integrated science. Why do we study integrated science? The first reason is that to understand the natural world and how it works. Then the second one is to develop a critical thinking and problem solving skills. The third one is to appreciate the interconnectedness of different scientific disciplines like life science, physical science, and earth science. Another one is to foster a scientific approach and inquiry and investigations. Then another one is to prepare learners for further studies and specialized science skills. Then the last one is to equip learners with practical skills applicable in everyday life and various careers. Question 46. Name 2 magnetic and non-magnetic materials. So in this case, we said magnetic materials. These are materials that can be attracted by a magnet, and most of the time are metals like iron. So in this case, we can have iron. We can also have steel, which is an alloy of iron. Then for non-magnetic material, these are materials which cannot be attracted by a magnet, and most of the time they are non-metals like wood, and also a plastic, even rubber, and many other non-magnetic substances. Then question 47. The diagram shows part of a human skin, and in this case it's labeled, we have a part labeled A, B, C, we have F, E, and D. Then the question is identify parts F, E, and D. So in this case, the part labeled F, E, and D, we can equate them to this diagram which is labeled here. The part which is labeled as E is this one here, which we call the oil glands. Then the part which is labeled F, the part labeled F is this one here, which we call the hair follicles. And then the part labeled D is this one here, which we call the fatty tissue. This is the D. So in this case, if we have to label them, then our F is going to be hair follicle, Then E is oil gland. Then we also have D, which is in this case our fatty tissues. Question 48. Study the diagram below. So in this case we have a diagram which is a female reproductive system with a part labeled M. Then the question is, what is the function of the part labeled M? This part labeled M, its name is a fallopian tube. This is a fallopian tube. And this fallopian tube serves three functions. The first one is that it transports the ovum. It carries the mature egg, which is an ovum, from the ovary to the uterus. Then the second function is that it's the site for fertilization. Fertilization takes place in the fallopian tube. This is where the sperm meets and fertilizes the ovum. Then the third one, it provides a suitable environment for early development of a fertilized egg, which we call the zygote. Then question 49, give two examples of common electrical appliances found at homes and the energy they convert. So in this case, we have the first appliance, which is an electric fan, which adds electrical energy to kinetic energy, and sometimes it can convert it to sound energy, because when a fan is rotating, it produces some sound and sometimes heat. The second one is electric kettle, and this one converts electrical energy to heat energy and sometimes the sound energy. Remember, when you are heating a substance using a electric kettle, there's some sound which is produced. So in this case, we must cater for it. Another one is a light bulb. This one converts electrical energy to light energy and sometimes heat energy. Then 4, we have a television, which converts electrical energy to light energy and sound energy. Then the last question, that's 50. The diagram below shows the SI unit table. Fill in the missing SI unit. So in this case, we have this quantity and the SI unit. We have time, we have length, we have mass. The SI unit of time is second, and then the SI unit of length is meter. The SI unit of mass is kilogram. And then we have other basic units or quantities, and we have listed them several times, but if I can repeat, already we have said length is meter, mass is kilogram, time is second, temperature is Kelvin, electric current is ampere, amount of substance is mole, luminous intensity is candela.